Good day everyone and welcome back for another video. I'm Yankee Oscar 6 Delta X-Ray Echo, and today we're going to talk about an antenna tuner. So in the past videos I've been playing around with various designs for the impedance transformer. Then I modified the 40 to 10 meters band end-fed half wave for 80 to 10 meters using the 85 microhenry inductor that I built. So we have a shortened end-fed half wave antenna that works from 80 to 10 meters. And in the very first videos that I posted on YouTube, I've been experimenting with two different antenna tuners. So I had two different designs, when I built those, what I had in my mind that I wanted to be able to use the antenna tuner both for high impedance input and also low impedance input. So what does it mean, high impedance? High impedance input is that you can connect the antenna directly to the antenna tuner, and on the output you match the impedance to the impedance of the transceiver, so 50 ohms. Low impedance, it means that you're actually getting the output coming from the impedance transformer, so the impedance is already low impedance, and you're trying to match that to the 50 ohms of the transceiver. So for example, on the 80 meters band, talking about the shortened end-fed half wave that we built recently, the 80 meters band has a very low bandwidth if you watch the video. So let's say I want to tune the antenna to work the best on the upper side, on the upper portion of the band, of the 80 meters band for SSB. And if I go right now on that portion of the band, my SWR is somewhere around, I don't know, 3 to 1 maybe. And I'm just giving a random example, probably it's not the same, but you get the idea. And the impedance is somewhere around 20 ohms maybe. So by connecting the signal coming from the output of the impedance transformer from my antenna right now, I can connect that one to the antenna tuner, and by playing around with the value of the capacitor and the inductor, I can get the best match between the antenna and the transceiver. So probably I'll get an SWR somewhere around 1 to 1 or 1.2 to 1, and the impedance should be closer to 50 ohms. So that's what we're going to build today, a simple antenna tuner. And for that I have this variable capacitor. I have this one as a present from my friend Adi. He owns a little store with components and stuff here in Brasov. It's called Mikado 2, and a really nice guy, passionate about radio and building speakers. He likes building custom speakers, and yeah, so he gifted me this one, and I thought I should use it for an antenna tuner. About the inductor, I'm still not sure if I'm going to use a PVC pipe inductor or a toroid version. I think this is T82-2. I purchased this one from my friends at Raw Waves. So I'm still going to think about it, about which one I'm going to use, but yeah, for now the schematic is really simple. Today I'm just going to test the impedance that I need to match the the impedance coming from the antenna to the transceiver. Probably I'm going to play around with this one, just because it's a lot easier to work with this one. And yeah, I'm just going to test to see what impedance I need, and if the value of this capacitor is enough to properly match every band from 80 to 10. So let's not waste any time. Let's try to make some tests, and in the future video I'm going to show you the finished version. And if I don't need a lot of capacitance, by the way, I might use one of those plastic variable capacitors because they're cheaper. These ones are harder and harder to find, and if you do find them, they're quite expensive. So yeah, and I'll try to make it small as well. So anyway, let's get going. I will now continue without saying thank you to my friends at PCBWay for always sponsoring and supporting the DX Explorer channel. They have great PCB prototyping services, PCB assembly, SMD stencils, CNC, 3D printing, and a lot more available for you. And if you're into DIY projects like me and you like designing your own PCB boards, I cannot recommend them enough. All you have to do is to register for your new account, and if you don't have one, just have a look in the video description because you'll get a link where you can register and you get a discount on your first order. After that, you just place your order and you wait for the order to arrive, and you can place the components on the board and finish your project so you have something nice that will last a long time. And by the way, you can also order assembled versions of each project. In my case, for example, if you want to order, you can either order the PCB boards or the assembled version if you don't feel like heating up that soldering iron. As I'm always saying, PCB way is the way. Okay, so here we are. I built this test jig over here, but you know, this is not ideal because you know, this one will introduce a lot of capacitance and so on, so it's not perfect, especially for what I'm trying to do over here. But because I'm trying to keep this video short, because the last one was like half an hour long, and probably the next one, you know, the part 2 of this video about the antenna tuner will be a lot longer than this one. So in here I just built this test jig trying to find out the optimal value of the inductance that I need in order to get the best SWR on each band. So obviously I try to keep the inductance as small as possible, but actually for the 80 meters band, for example, the highest value inductance was around 22 microhenries. So I don't know how I'm going to fit that on the toroid, which by the way, it's actually a lot bigger than I thought. So it's not 82-2, it's actually 106-2, so it's a little bit bigger. But yeah, on this one I'm going to have to fit those 22 microhenries, so I need to calculate the number of turns that I need for 22 microhenries, which is the maximum inductance that I need to be able to tune the ATU on the 80 meters band. So when it comes to the capacitor, I decided to use the tiny one, which is around 150-160 picofarads, something around there, and I did not use the big one. I actually tested with this one as well, because I thought that if I put way more capacitance, it will actually tune it and I won't need such a higher inductance. But it seems that even like that, with that one, I still have to use 22 microhenries on the 80 meters band. So here, for example, we are on the 10 meters band, and the inductor that I'm using right now for the 10 meters band, it's 2.2 microhenries. So as you can tell, I can tune the 10 meters band pretty well using that inductance. And I'm just moving the variable capacitor slowly, and I'm able to pretty much use the entire 10 meters band, which is great. It goes all the way up to the to 30 megahertz, so it's not bad. Let's take another band, for example. I'm going to leave the 2.2, no, actually let me leave the 2.2 microhenry, and I'm going to go to the 20 meters band, because I think that one also uses, now that the 20 meters band performs better with only 1 microhenry, but I'm going to do it with 2.2 just to show you, like a quick demo. 14.35 megahertz, and look over here. Even with 2.2 microhenries, we're getting a good SWR across the band. But with 1 microhenry, I'm getting even better results toward the top of the band on the SSB portion of the band, close to 14.350. But even like this, it's not bad at all. I don't know what I have, the 1 microhenry inductor. So I'm not going to waste your time right now, but you know, this is the idea. This is what I've done. I have a bunch of fixed inductors over here, and I tested different values for each band, trying to see what's the best inductance value that I need in order to get the best SWR across the band. Just a quick example, on the 80 meters band, I can actually use a lower inductance, and I will get better results probably towards the end of the band, but then the SWR won't be so good towards the beginning of the band, so, or the other way around, you know. So I try to get an even SWR across the band. So here are the results. By the way, this is a schematic for a tone generator, a sine wave tone generator for, you know, like if you want to practice Morse code. Probably I'm going to make a video about that one as well. I made this one for a friend. So the value of the variable capacitor over here is somewhere around 150, 160 picofarads. This one is somewhere around 500 picofarads, but turns out that I didn't need all those picofarads. So I decided to stay with a smaller one just because I'm trying to design a PCB board for this one, so we can build a tiny ATU that we can install in a small enclosure, and we can also use it for portable if you want to, together with the end-fed half-wave antenna and the 49:1 impedance transformer. So here we are. The results that I've got for the 80 meters band, I needed 22 microhenries. For the 60 meters band, which I can't use here in Romania, but I tested it anyway, it's 10 plus 6.8, so it's somewhere around 16, 17 microhenries. That's the best result that you get on the 60 meters band. Over here with about 13, 14 microhenries, you get the best results on the 40 meters band. On the on the 20 meters band, the best result I got with 1 microhenry. On the 10 meters band with 2.2 or 2 microhenries, on 12 meters with 3.3 microhenries, on the 15 meters band with 4.7 microhenries, on 70 meters I have the best results with 6.8 microhenries, and where else? On the 30 meters band, it's again somewhere around 16, 17 microhenries, same as it was for the 60 meters band. So yeah, my next step, probably in the next video, it will be to calculate and build this variable inductor, and I'll show you in a little bit the switch that I'm going to use together with this one. I'll try to see if I can install this one on that switch and see how many points I have that I can. It's like a rotary switch, and I'm trying to see how many positions it has, and if I can cover all these values over here. And if I cannot cover all these values, I'll try to find the best value, you know, like the optimal value that I can get for each band, but with only those positions that I have available on the switch. So yeah, sorry for the noise, by the way. It's really windy, and my camper, it feels like I'm back on the sailboat in the Atlantic. So yeah, I'm going to use this one at the end. I'm not going to use the PVC pipe version, just because I'm going to try to build something really small and also design a PCB board that you can always order, and you'll be able to you know, to build your own ATU. On the screen right now you have the schematic of this thing that I have over here. It's basically a capacitor and the inductor in series. So if you want to build it for high impedance input, you know, like to connect the antenna directly, the antenna wire to the ATU, not like low impedance right now, the way it is, you know, having the signal coming from the 49:1 impedance transformer, and then it comes to the ATU, which is already low impedance to low impedance sort of thing. So yeah, if you want high impedance, then you will have like an L match. I'll put that schematic on the screen right now as well, so you get to see how the L match looks like. And yeah, if you want to be versatile, you can use a switch and change it from L match to a series, and you'll be able to use the antenna tuner both with high impedance and low impedance. But I'm not going to bother with that. I'm going to keep mine simple and use it only with low impedance. So that's it for today, because I don't want to end up with a long video like 30 minutes like the last one that I just posted. We'll speak more about this and the schematic, the final schematic that I ended up with in the next video, the final one about the antenna tuner. But I'm glad that in this video I did find out the value of the inductors. You know, now I know how to build the variable inductor, you know, how many taps I need, and I'm going to place this one on top of the rotary switch, so it won't take so much space on the PCB board. I'll design a PCB board as well. I'm glad that I can use the small capacitor because it's going to be cheap as well. And yeah, it's very, very simple. I mean, I'm going to also add an SWR bridge, you know, the kind of bridge with an LED that you can actually see when you have the best SWR. You're going to transmit with like really low power, and you'll be able to tune the antenna tuner by keeping an eye on the brightness of the LED. So the brighter it is, the bigger the SWR, the lowest the brightness, the best SWR you get. So yeah, that's something that I'm going to put into this as well. And yeah, I hope it helps, and if you're planning to build something, yeah, you can get some information about the value of the inductors, so you don't have to waste your time measuring. I'm pretty sure you can build better antenna tuners, and you know you have more options. If you have that rotary variable inductor, that one it's even better than what I'm using over here. You know, the big roller inductors, those are much better. And if you're using a variable capacitor with a bigger space between the elements over here, you can also use it for bigger power. But yeah, I'm just going to stick to QRP for now, so this should be okay. So yeah, I'll see you in the next video. I won't waste any more of your time. I hope you have a wonderful Sunday, and until then, 73 from Yankee Oscar 6 Delta X-Ray Echo.